Hey everybody, this is going to be a video on naming ionic compounds with polyatomic ions. So in order to start this, you have to know how to identify what a polyatomic ion is. I have this list listed here. You probably will have a list given to you. And you can see that they all have different charges. Oh, I think the positive one is kind of hiding down here. And if you look up here, this is your polyatomic ions with -1 charge or one negative. And these ones are your 2 negative, and this one, ammonium ion, is the one that has a 1 positive charge. So it's really important to know the charges, because when you're combining ionically, it's really the transfer of the electrons, and your charges after bonding has to be neutral. It has to be 0. It has to result in a 0 charge. So how do we look at this? We have something like sodium hydroxide. So this one is given to you in the name. So sodium hydroxide. This is similar to how you name ionic compounds, except that you can notice that hydroxide is not something you can find on the periodic table. If you go back, if I were to go back, you can see the hydroxide, or there is a hydroxide ion. So hydroxide, this polyatomic ion, OH negative, is always by itself. So if we were to name this, name it just like how you would name it in ionic bonds. Sodium is Na, and remember, Na has a 1 positive charge. Hydroxide, if we were to go back to the slide, you can see on this table, hydroxide ion for the OH has a -1 charge. So we're going to write OH. We're going to keep this all together because that's what a polyatomic ion is. So this is going to be 1-. Since they are in a compound, the charges have to be equal. So that means that if you add 1 positive to 1-, they have to equal to 0, which in this case is true. So in this ratio, your chemical formula is NaOH. So that's the first one. Now the next one, you're going to see ammonium chloride. That's the name. Can you find ammonium on your periodic table? If you look for it, you probably won't find it because it's not there, because ammonium is a polyatomic. So if you look at here, ammonium is down here, it's NH4+. So this one has a 1+ charge. That's very important. So I'm going to write NH4 1+ charge. And then the next one, chloride, is actually found on your periodic table as chlorine. So Cl, you should know at this point, has a 1- charge. So again, when you're forming compounds, the charges, they have to cancel each other out, as in they have to equal to 0. So you have 1+, 1-, that's going to equal to 0. So then that's your ratio. You're going to have 1 for every 1 NH4 ammonium ion, you're going to have 1 Cl. So that's your formula. Next one, the third one, sodium chromate. So immediately I can see sodium is something I can find on the periodic table. I'm going to write Na, and I know it has a 1+ charge. What about chromate? This is not chromium because it has the ending ATE. So let's look at your polyatomic. So this is not, oh, this is chlorate. I'm looking for chromate. Oh, I can see chromate right here. So chromate has the formula Cr, which is chromium with 4 oxygens, and has a 2- charge. So we're going to keep that in mind. So that's going to be CrO4 2-. And again, remember, the charges have to cancel. So we're going to look at this one. For sodium, it's a 1 positive, and chromate is 2 negative. Well, we can see that they're 1 bigger for chromate, so we need 2 of these sodium ions. So we're going to have Na2, because if we multiply sodium by 2 times this, it's going to be 2+. And then how many chromates do I need? I just need 1, because your 2- is going to cancel out with the 2 positive. So that's my ratio. And the last one is ammonium phosphate. I can see that ammonium, from experience or from looking at this table, ammonium is right here. That's your polyatomic, as it is NH4 1 positive. And phosphate is not phosphorus because it has ATE, so this is not on your periodic table. So go back to your polyatomic, and we're going to look for phosphate. Phosphate ion right here has a 3- charge, and it's P phosphorus with 4 oxygens. So that's going to be PO4 3-. And we have to balance the charges out. So you're going to see that phosphorus has a 3-, ammonium has a 1+, plus. So we need 3 of these ammoniums, 3 times 1 plus to get it to equal to or cancels out with the 3 minus. So my final formula is NH4, that's my ammonium. Since I need 3 ammoniums, I need to create brackets, so I have 3. And PO4, I just need 1 molecule of that. So that's my formula. So then the question is, how do we go backwards if you're given the formula name? So it's pretty straightforward. It's actually easier than writing it into formula, because you're just going to write it how you name it for ionic compound. So Na, you can see that we can split this in 2. One side is your cation, one is your anion, which is your negative. Na is your sodium, so I'm just going to write sodium. That name doesn't change, it's going to stay the same. Cn, we're not going to name this carbon nitrogen, because Cn, if you look at your polyatomic, we can actually see that Cn negative is an ion that is named cyanide. So instead of changing the name, we're just going to keep the name cyanide, and that's how you name it, sodium cyanide. Okay, so if you look at this, cyanide, it stays the same. The next one, magnesium, well, MgNO3, and it has a bracket of 2. The reason why we have this 2, if you look at the charges, Mg is 2 plus. Every 1 nitrate or NO3 is 1 minus. So that's why we need 2 of them, because we need to multiply that by 2 to make this 2 minus to cancel the charges. How do we name this? Well, Mg is found in the periodic table as magnesium, so we're just going to write magnesium, it doesn't change. And NO3 is a polyatomic, so look in here, where's nitrate? Right here, NO3 minus. We're not going to change this name, we're not going to name ion, because once it's bond to something, it's not ion anymore. So we're just going to keep this name as nitrate, and that's what you're going to write. So magnesium, nitrate, and that's how you name it. And the last example is NH4, and we have 2 of them, and then we have an SO4. You can see that there's 1, 2, 3, and 4 different types of elements, but we can still see that NH4 is a polyatomic, right? This is what we used earlier. So that's ammonium. Do I care about the charges when I'm naming? Not really. I'm just going to keep the same name. And SO4, if we look at your as polyatomic list, SO4 is right here. And that's called sulfate. So you're going to keep this name, sulfate, and that's how you name it. So that's it, ammonium sulfate. Oh, sulfate. And that's how you name from formula to a name, and that's also how you name from a name to a formula. So whenever you're writing your formula, make sure you're balancing the charges. But when you're just going to the name, you don't need to do the charges. And that's how you name ionic compounds with polyatomic ions. So I'll see you later.